All right, let's get into it. Today, we're tackling one of the biggest questions in AI. Why is it so hard to understand how these systems actually make their decisions? It's something people call the black box problem, and we're going to break it down and then look at a fascinating blueprint for building AI that's not a black box, but a glass box, totally transparent and trustworthy. Okay, just to set the stage, imagine this. You wake up, you check your email, and there it is, a notification that an automated system has flagged your performance and you're being let go right now. Just like that, your life has been completely turned upside down, and the decision was made by an algorithm. So, of course, you ask why. You want to see the data. You want to understand the logic. But nobody can tell you. The answer they give you, it came from an AI, and how it works, well, that's a mystery. It's this feeling of being completely powerless. And that situation right there, that is a perfect, real-world example of what we call the black box problem. It's really the heart of why so many of us struggle to trust AI systems, especially as they start making more and more critical decisions that affect our lives. So what is a black box AI really? Well, it's pretty much what it sounds like. It's any system where you can't see the inner workings. You put data in one side, a decision pops out the other side, but that whole process in the middle, it's completely opaque. You can't check its work, you can't question its reasoning, you pretty much just have to take its word for it. So why are they so opaque? Well, it's a mix of a few things. Modern AI can be probabilistic, which just means it might give you a slightly different answer every time you run it. There can also be hidden prompts or data that are quietly steering the output in a certain direction. And here's the really tricky part. An operator could just keep running the AI over and over until they get the answer they want. That's a thing called p-hacking or outcome shopping. And the audit logs we have now, they just tell you the final result, not the messy, potentially biased journey it took to get there. This really lays out the two worlds we're talking about, doesn't it? On one hand, you have the black box of today, opaque, unpredictable, and totally unverifiable. And on the other, you have the goal, a glass box AI, something that's transparent, repeatable, and provable. So the huge question is, how do we get from here to there? And this is where things get really exciting. We're not just talking about the problem, we're talking about a detailed blueprint for actually building this new kind of verifiable AI. So let's dig into how it actually works. The whole solution really stands on three core ideas, three pillars. You've got the cleanroom environment, the immutable recipe, and something called the pre-committed dice roll. Let's take a look at what each one of these actually means. So first up, the clean room. The best way to think about this is like a super sterile scientific lab, where every single tool, every substance, even the air is perfectly accounted for. That's the idea here. The AI's entire software environment is built from pieces that each have a unique digital fingerprint, a cryptographic hash. This makes sure that the AI's thinking space is completely sealed, perfectly known, and you can verify that nothing has been tampered with. Pillar number 2 is the immutable recipe. Now, immutable just means it can't be changed. So every single piece of the AI's process, the models it uses, the prompts it's given, the rules it follows, everything is locked down with its own unique hash. If you change a single comma in a prompt, boom, you get a brand new recipe with a brand new digital signature. This gives you a perfect, unbroken chain of evidence. And that brings us to the third, and honestly, most clever pillar, the pre-committed dice roll. See, AIs often use a bit of randomness to be creative, but that's what makes them unpredictable. This pillar solves that problem. It basically forces the system to decide on all its random dice rolls before the process even starts. It's like a casino announcing the exact order of a fully shuffled deck of cards before a single hand is even dealt. And the crucial result of that, this pre-commitment makes that outcome shopping we talked about earlier structurally impossible. No one can just keep re-rolling the dice behind the scenes hoping for a better answer. The randomness is locked in from the very beginning, which completely removes that key avenue for human manipulation. Okay, so you have the clean room, the immutable recipe, and the pre-committed dice roll. When you put all three of these pillars together, you get the real breakthrough here. This is the ultimate payoff. This quote really just nails it. The output was the inevitable consequence. What that means is that the system can prove with cryptographic certainty that for the exact inputs and rules it was given, the result it produced was the only possible result. It proves it could not have behaved any other way. So how does it prove it? It generates something called a replayable log. Now, this is not your typical log file that just says, decision approved. No, this log is the complete recipe. It contains all the unique digital fingerprints for the clean room, the immutable recipe, and that pre-committed dice roll. Anyone, a regulator, a judge, or you, can take this log and perfectly replay the AI's entire computational path, step by step, and you will always arrive at the exact same result. I mean, that's a huge leap, right? It takes an AI's decision from being a mysterious opinion to a verifiable computation. But this isn't just theory. Let's look at what this actually means in the real world. For starters, think about content moderation online. It's a huge mess of controversy. With a system like this, a platform could actually prove that when a post was taken down, it was the inevitable result of their public policies. This isn't about arguing if the policy is good or bad, but it proves the rules were applied consistently, which could go a long way in rebuilding trust. And let's go back to our story about being fired by an algorithm. This same technology could completely change hiring. You could use it to prove that every single job candidate was evaluated using the exact same criteria through the exact same process. It gives both the company and the candidate cryptographic proof that the process was fair. In science, this is a potential solution to the replication crisis, where other scientists can't reproduce the results of a study. This system would stop that p-hacking by forcing researchers to lock in their analysis plan beforehand. It would ensure that scientific results are genuine discoveries, not just someone cherry-picking the data until they find something that looks good. And then you've got high-stakes areas like finance. This provides what you might call regulatory-grade proof. A bank could show a regulator or a customer who was denied a loan that the decision was made strictly according to the law, with undeniable cryptographic evidence that would stand up in any audit or court. So when you look at all of these applications together, it becomes really clear that this is more than just a cool tech upgrade. This is about setting a brand new standard for what we should expect and what we should demand from the AI systems that have so much power over our lives. And that really brings us to the final crucial takeaway. The technology to build AI that is accountable, transparent, and provably fair, it exists now. We have the ability to turn these opaque judgments into verifiable computations. So the question it leaves us with is a simple one. Now that we know this is possible, should we ever accept anything less?